ang sunod. So kani siya is ma-open gud ni siya ha, ma-open gud ni kung ato gud ni siyang i-open, ma-open gud na siya niya. Pwede na ta dito mag-demo. Okay. So kani is the internal vulnerability scanning. So appeal diri si na diri si Nesos, no? Na diri si Nesos ha. So kato kong giyaw-yaw, na diri si ping ana. Yan napay uban diri si MBSA, si software scan and the open bus. So ang last nato is the open source na scanning, no? So custom sa router Frameware. So para dili mo ma-overloaded sa video kay na-overloaded na mo sa kung yaw-yaw ganiha nga naglisod mo sabot ha mo ya kung kuan karon so ato lang tan-awon ang time alas 8 alas 9:30 naman ta so yan maputol man. So kanilang duha external, then ang internal by next Friday na siya before ko mohatag ninyo quiz. Ang akong quiz, ang theory katong akong gipangyaw-yaw mao to. So gamay ra kayo nga mogawas ani na dili ra ko mag kay hands-on man gud ni siya kaning video. So ani lang. So inig ka Friday iuna ko ni ko man mo out ta inig out na to una pa ko mohatag ninyo quiz. No? So ana okay ra mo or hot doon na tong video karon? Wala lang siya. Okay, play ni nato. Nanihinay sa dakong connection, no? Namsa naman na akong laptop ron, ni kamang naman eh. Asa ni siya padoong nagkamang, bro, siya good. Wala itingo, bensa.
Links is most people's networking like this. In the middle, we've got the router, which could be a Linksys, a Netgear, a D-Link, 3Com, BT, whatever. The router is connected directly to the internet via some sort of cable, which we've got illustrated here. You might have wireless or Wi-Fi devices, such as these, like laptops, phones, tablets. These are all connected to the router. And possibly wired connections to the router exist as well via Ethernet. Maybe you've got a printer or a desktop, and maybe a couple of pretty much it. The router is the central component of both your network and your security. The router is usually the default gateway for all traffic to the internet. So you come here, and this sends you off to the internet. To find out the IP address of your router, you need to look for what is the default gateway on your devices. And if you don't know how to do that, this is how you do it. In Windows, it is root print. There's a lot of information there, but this is because there's a lot on this machine. But there we go, IPv4 root table, and there you can see the gateway. 172.16.192.2. You can also try ipconfig, and you just need to find the right adapter. So in this case, it's this one, the Ethernet adapter, and there you go. Default gateway. More than likely will be your router. It will be a router of some sort. If you have one router, it'll be this one, unless you're using a virtual machine. On Linux, you can try sudo root -n, and there you go. On this one, you can see 10.0.2.2. And on Mac OS X, it's root -n get default. And there we can see 192.168.1.1. Your router's IP address is likely to be 192.168.1.1 or 192.168.1.254. Those are the most common IP addresses for your router. And if that still didn't help finding the IP address of your router, you can check out this link here, list of common default router IP addresses. And if you scroll down, you can see the defaults for the various router brands. As you can see, 192.168.1.1 is pretty common, and also 254. But most of you technical people on the course will already know your router's IP address. If you're not familiar, whenever you access a device via an IP address, you access it via a port. You can think of these ports as doorways into the device, and each doorway hosts a different service. These are the well-known ports. So for example, 22 is SSH remote login, which is for remote encrypted command line login, and lots of other pretty cool stuff. We have a section on SSH. There's Telnet here. Telnet is remote unencrypted command line login. Simple mail transfer protocol, SMTP, for sending mail. We'll be talking more about that in the section on email security. Port 80, as I'm sure you're aware, HTTP for web servers and web pages, as we've already discussed. And again, as we've already discussed, port 443 or HTTPS or encrypted HTTP using TLS SSL. Most routers are administered via a web interface like this on port 80 or 443 for SSL TLS, and or possibly SSH on port 22, and maybe Telnet on port 23. You would like to have set up your router via a web interface, and it probably looks something like this. Hopefully you still have your admin or root username and password. Often it's written on the back of the router if you're not sure. But also you can check here, this is website routerpasswords.com, if you're not quite sure what your password might be, and if you look for the manufacturer, find the passwords, there's a lot of default passwords in here. Or use your favorite search engine and search for your router model and the default password, and you might be able to find something. The router provides a vitally important role in shielding the internal devices from the internet. The router will have an external IP address, which will be here, and it also has an internal IP address that your devices communicate with, what you saw as the default gateway. To determine what the external IP address is, you can use a service like this. What is my IP address.com, and this will show you the IP address that you are representing to the world or to the internet, and that will be your internet service provider assigned IP address. In almost all cases, no one will be able to make direct connection to your internal devices via the internet. This is because of a service called NAT, or Network Address Translation. And because of that, you would have to specifically configure within the router to forward traffic to a specific device on a specific port in order for internet devices to connect to your internal devices. This is often called port forwarding, or a DMZ, or demilitarized zone. This is an example configuration of port forwarding, where the router is allowing external devices from the internet to connect to internal devices. And we have 4 internal devices here that are being connected to. The top example is this sling box. People are able to connect to the router IP address on port 5001 using TCP or UDP. When that traffic gets to the router and reaches that port, it forwards it onto this internal device 192.168.1.55 on its port 5001. And without these port forwarding rules, and if you've got NAT, nothing from the internet can directly connect to you. When you make connections out of the router to the internet, say for example when you're browsing the web, the router remembers who you've connected to and allows them to send traffic back to you in response to your request. This is called maintaining state and will be configured by default. So they can communicate back to you as long as you've initiated the connection. NAT, or Network Address Translation, provides a very useful security function as it operates as a deny all rule to any attempt to connect to internal devices unless port forwarding is specifically enabled to allow access. What we call a router these days is technically several devices together in one device. Although it is possible to have these devices separate, and you might have that on your own network, but typically home routers now are a collection of components with distinct roles, as you can see here in the middle: switch, firewall, router, modem, wireless access point. Switches, which are where the network cables are plugged in, that's the switch. Switches keep a table of Ethernet MAC addresses called a MAC table. It uses these unique MAC addresses for your devices to send traffic to its destination on the LAN, and works at the data link layer, layer 2. Once data is traveling on your local network, IP addresses are not used anymore. MAC addresses are used for traffic to find its destination to the local network. IP addresses are only used on the internet and when you have some sort of routing device. When you have just a switch or a hub, then you're only using MAC addresses. Switches offer more security over hubs because switches have what is called isolated collision domains, which is a fancy way to say that you can't sniff the traffic on the network with a switch, because traffic only gets forwarded to the correct physical LAN port based on the MAC address. So when traffic goes into the switch or the router, the switch knows what the MAC address is, so instead of sending that data to all the devices, it just sends it to that one physical port and down that wire. Therefore, anyone else who's plugged into that switch won't receive that data. That's the isolated collision domain. Things work slightly differently in wireless. There are ways to defeat this isolated collision domain with ARP spoofing, which we will discuss later. Firewalls, they are used to allow and deny traffic based on a set of rules. IP tables is the software commonly used as the firewall on many routers, which works on the network and transport layers, layers 3 and 4, to accept or reject traffic based on port, protocol, and IP address. Firewalls can work at the application layer, layer 7, which is known as a deep packet inspection firewall, or can be called a proxy firewall or application firewall, but these aren't usually in a router. You are likely to have IP tables in your router, if anything at all. And importantly, firewalls also keep logs of traffic if they are configured to do so. If you have a basic router, it is unlikely to log, and the firewall will be very limited if you have a firewall at all. Routers have within them routers, which of course is their namesake, but an actual router that is just a router routes traffic from one network to another based on information in the IP routing table within the router. On a local network, this is usually from the LAN to the WAN, or the local network to the internet. So essentially, the router's function is to pass network traffic from your local network to the internet, and from the internet to your local network. Routers work at layer 3 and route IP packets between networks. Something is a different network when it has a different subnet. Modems, they modulate and demodulate the signal so it can be passed onto the local loop of your network carrier. It works at the physical layer to start sending the photons and electrons onto the internet. And you may also have something called a bridge, which forwards packets and filters based on MAC addresses. It forwards broadcast traffic, but not collisions. And it works at the data link layer, layer 2. The wireless access point. This works similar to the switch, but for wireless devices. It is the wireless transmitter and receiver built into your router. It uses the unique MAC addresses of your devices to send traffic to their destination, and works at the data link layer, layer 2. Some of you may have a separate wireless access point, but nowadays, often they are built into the router, same with the switch, the firewall, and the modem. Routers also offer services like DHCP, which assigns your IP addresses to your devices, DNS to resolve domain names into IP addresses, port forwarding as we showed, and network address translation as we talked about. So there's a lot there in networking, and if you're not really fully up to speed with networking, then you may have to study around this, because this is not a course just on networking. So those are the basics of networking. You may need to dig into it a little bit more if you didn't really understand most of that.
Okay, so ang kaning video okay, nagkuha niya siya on sa connection sa network na tato ang mga router, mga modem, mga iyon ana. So yes, kanang pila ka buok ang nagamit og naay router sa inyong connection